Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the solutions. The weightage of the solutions in ECET examinations is 3 marks. A solution can be defined as a homogeneous mixture of two or more substances. So, a solution contains two or more substances. Coming to the examples, air, sugar solution, salt solution, and soda water are good examples of solutions. A solution containing only two components is called binary solution. So, a binary solution contains how many components? It contains only two components. And the two components of a binary solution are solvent and a solute. Solvent means the component which is present in a larger proportion. Solute means the component which is present in a smaller proportion. Let us consider a salt solution or a sugar solution. So, salt is the solute whereas the water is the solvent. And always remember that it is possible to separate the components of the solution by following the physical methods. Paper chromatography is highly useful with respect to the food industry. Filtration method is highly useful for the separation of insoluble solid from a liquid, and the other methods includes evaporation, distillation, fractional distillation, etc. Is it clear about the binary solutions? Coming to the classification of solutions, they can be classified either based upon the physical state or based upon the relative amounts of the solute present in the solution. So, coming to the classification of solutions based upon the physical state, all the solutions can be classified into three categories, namely solid solutions, liquid solutions, and gaseous solutions. Again, each category can be classified into three types based upon the physical state of the solute. Coming to the examples, alloys are good examples of solid in solid system. Amalgams like zinc amalgam, sodium amalgam, these are good examples for liquid in solid systems. H2 over palladium is good example for gas in solid system. Salt in water is good example for solid in liquid systems. The most general category of solutions includes solid in liquid systems. Coming to the alcohol in water, it is good example for liquid in liquid system. Soda water is good example for gas in liquid system. Camphor in air and smoke are good examples of solid in gas system. Water in air, that means moisture, is good example for liquid in gaseous system. Air is good example for gas in gas systems. Is it clear about the classification of solutions based upon the physical state, students? Next, coming to the classification of solutions based upon the relative amounts of the dissolved solute, all the solutions can be classified into three categories. They include saturated solution, unsaturated solution, and supersaturated solutions. Coming to the saturated solutions generally contains maximum amount of dissolved solute at a given temperature. From this definition, it is very clear that the presence of the amount of solute in a solution depends upon the temperature. As the temperature increases, the amount of solute present in a solution also increases. So, always in a saturated solution, there exists a dynamic equilibrium between the undissolved solute and the dissolved solute. So, that means in a saturated solution, always two types of processes takes place. One being the dissolution of the solute and the other one is recrystallization of the solute. Both takes place in opposite direction. Simply we can say that in a saturated solution, always there exists a dynamic equilibrium between the solution and the excess of solute. Is it clear about the saturated solution, students? Next, coming to the unsaturated solution. Unsaturated solutions contains less amount of the dissolved solute when compared with the saturated solution at a given temperature. Good examples of Unsaturated solution includes salt water system, sugar water system. Clear, students? Coming to the supersaturated solutions, generally they contains more amount of dissolved solute than required for the saturated solution. Supersaturated solution is also called as the metastable solution. Of the three types of the solutions, saturated solution is the most stable solution, whereas supersaturated solution is the most unstable solution. The substances which can form supersaturated solutions includes sodium acetate, hypo. Remember, always the amount of the solute present in a solution depends upon the temperature. That means whenever if we consider a saturated solution, if the saturated solution is heated, it becomes unsaturated solution, and vice versa. That means whenever an unsaturated solution is cooled, it becomes a saturated solution. Is it clear about the classification of the solutions based upon the relative amounts of the dissolved solute, students? Next, we will discuss about the solubility and the concentration terms. Coming to the solubility, the quantity of solute required to saturate 100 grams of a solvent at a given temperature is called as the solubility. So, simply the amount of solute present in 100 grams of the solvent is called as the solubility. So, mathematically it can be expressed as S is equal to small w by capital W into 100. So, it is the ratio between the amounts of solute and the solvent, and it has no units. Coming to the concentration, the amount of the solute present in unit volume of the solution is called concentration. Students, what is meant by concentration? It is the amount of the solute present per unit volume of the solution. And remember that always if the concentration of the solution is known, that is called as a standard solution, and if the concentration of the solution is not known, if the concentration of the solution is unknown, that is called as a problem solution. We are having both physical and chemical terms to express the concentration. So, coming to the physical methods, it includes weight percentage method, volume percentage method, weight by volume method, ppm, etc. And our point of interest is to discuss in detail about the chemical methods. Chemical methods generally includes molarity, molality, normality, and mole fraction. So, what are the chemical methods used to express concentration? Molarity, molality, normality, and molality, mole fraction. So, we are going to discuss in brief about each and every term. Coming to the molarity, the number of moles of solute present per 1 liter of the solution is called molarity. So, it is the ratio between number of moles of the solute to the volume of the solution in liters. So, the number of moles can be calculated by using the formula weight of the solute divided by gram molecular weight of the solute. So, on the whole, what is the expression for molarity? That is equal to weight of solute divided by gram molecular weight of the solute into 1000 by volume of the solution in mLs. Coming to the units, units of molarity is equal to moles per liter. Students, is it clear about the molarity? Next, we will discuss about the formulae related to molarity. So, for dilution, we use the expression M1V1 is equal to M2V2. For a mixed solution, the molarity can be obtained by using the expression M1V1 plus M2V2 by V1 plus V2. So, coming to the volume of water to be added, that can be calculated by using the expression M1 minus M2 by M2 into V1. In the case of acid-base titrations or neutralization titrations, the expression used is M1 V1 by N1 equal to M2 V2 by N2. In order to know the values of N1 and N2, always we have to consider the chemical reaction between the acid and the base. So for example, let us consider whenever sodium carbonate solution is titrated against HCl, what happens? Sodium carbonate reacts with HCl and it results in the formation of NaCl plus water plus carbon dioxide. Here what is our concentration? To know about the number of moles. So the number of moles of acid N1 is equal to 2 and the number of moles of base N2 is equal to 1. Is it clear how to calculate N1 and N2 in the case of acid-base titration, students? Let us see few examples. Calculate the molarity of 4% NaOH solution. So 4% NaOH solution means 4 grams of NaOH is dissolved in 100 ml of the solution. So coming to the molarity is equal to weight by gram molecular weight into 1000 by V. So that is equal to 4 by 40 into 1000 by 100 and the molarity of the resulting solution is equal to 1 molar. Coming to the next problem. 5.3 grams of sodium carbonate is dissolved in 500 ml of water. What is the molarity of the solution? Here weight of the sodium carbonate is 5.3 grams. Gram molecular weight is 106. Volume of the solution is 500 ml. So directly by substituting all these values, we will get the molarity of the solution as 0.1 molar. Let us see one more problem, that is how much volume of water should be added to 100 ml of 0.05 molar solution to get a solution of 0.01 molar. So here we are supposed to calculate the volume of water to be added. Here the M1 is equal to 0.05 molar whereas M2 is equal to 0.01 molar and the V1 is equal to 100 ml. Let us substitute all these values in the expression M1 minus M2 by M2 into V1. Then we will get 400 ml. So 400 ml of water to be added to get the 0.01 molar solution. And coming to the another problem, 20 ml of 0.01 molar NaOH solution reacts with 18 ml of sulfuric acid. Find the molarity of the sulfuric acid. So it comes under acid-base titration. So let us consider first of all acid followed by the base. Here we have to know the values of N1 and N2. So here what happens? Sulfuric acid reacts with NaOH. So from this expression, what is the value of acid? N1 is equal to 1. So the number of moles of sulfuric acid is here 1. And N2 is the number of moles of NaOH. In this case, N2 is equal to 2. By substituting all these values in the given expression, that means M1 V1 by N1 is equal to M2 V2 by N2. That implies M1 is equal to M2 V2 by N2 into N1 by V1. That is equal to 0.01 into 20 divided by 2 into 1 by 18. Finally, we will get the molarity of the solution as 0.005 molar. This is about the few problems related to molarity. Coming to the normality, it can be defined as the number of gram equivalents of solute present per 1 liter of the solution. How to calculate the number of gram equivalents of a solute? So always weight by gram equivalent weight gives the number of gram equivalents. So what are the units of normality? It is gram equivalents per liter. Finally, the normality of any solution can be calculated by using the expression N is equal to weight by gram equivalent weight into 1000 by V in ml. Coming to the formulae, dilution law includes N1 V1 is equal to N2 V2. Here always remember we require a relation between molarity and normality. So always the normality is equal to molarity into charge on cation or an anion. So let us see few problems related to normality. 9.8 grams of sulfuric acid is dissolved in 2 liters of water. Calculate the normality of a solution. So weight of the solute W is equal to 9.8 grams. Volume of the solution V is equal to 2 liters. What is the gram equivalent weight of the sulfuric acid? So it can be obtained by calculating gram molecular weight by 2. So that is equal to 49. So what is the expression for gram equivalent weight? Gram molecular weight by valency. So here the gram equivalent weight of the sulfuric acid is equal to 49. So normality is equal to weight by gram equivalent weight into 1 by volume in liters. That is equal to 9.8 divided by 49 into 1 by 2. And finally, the normality of the solution is 0.1 normal. Coming to the molality, the number of moles of solute present in 1 kg of solvent is called as molality. Remember that molality is expressed in terms of weight by gram molecular weight, and it is applicable for the solid solutions. That means both solute and solvent are present in the solid state, and hence temperature will have negligible effect. Coming to the problem, what is the molality of a solution containing 4 grams of NaOH in 500 grams of water? So what is the weight of the NaOH? That is equal to 4 grams. What is the weight of the water? That is equal to 500 grams. Gram molecular weight of NaOH is equal to 40. So molality is equal to weight by gram molecular weight into 1000 by weight in grams. That is equal to 4 by 40 into 1000 by 500, and hence finally the molality of the solution is equal to 0.2 molal. And always remember that molality is independent of temperature. Why? Both solute and solvent are present in the solid state. Is it clear? So always remember molality is independent of temperature, since both solute and solvent are present in the solid state. And finally coming to the mole fraction. Before knowing about mole fraction, one should know what is meant by a mole. Mole means the quantity of the substance contains Avogadro number of particles. So what is the value of Avogadro's number? It is 6.023 into 10 power 23. Then how to calculate number of moles? Always weight by gram molecular weight gives number of moles. And coming to the mole fraction, it can be defined as the ratio between the number of moles of a component to the total number of moles present in a solution. Let us suppose that small n is the number of moles of the solute, capital N is the number of moles of the solvent. Then the mole fraction of the solute, small x is equal to small n by small n plus capital N. And similarly, coming to the mole fraction of the solvent, it is represented by capital X, that is equal to capital N divided by small n plus capital N. From these two expressions, it is very clear that always the mole fraction of solute and mole fraction of solvent is equal to 1. So, sum of the mole fractions of solute and solvent is always equal to 1. Let us calculate the number of moles of water. So, the number of moles present in 90 grams of water. So, number of moles is equal to weight by gram molecular weight. That is equal to 90 by 18, and that is equal to 5. Is it clear about the mole fraction, students? Let us consider one more problem. A solution of urea is prepared by dissolving 180 grams of it in 1 kg of water. Find the mole fraction of urea. So here the solute is urea. What is the formula of urea? That is NH2CONH2, and hence its gram molecular weight is 60. So coming to the urea, weight of the urea is equal to 180 grams. Gram molecular weight of urea is equal to 60 grams, and hence the number of moles of urea is equal to 180 by 60, that is equal to 3. Coming to the water, weight of water is 1 kg, that means 1000 grams. Gram molecular weight of the water is equal to 18. So the number of moles of water is equal to 1000 by 18, and that is equal to 55.5. So we are supposed to calculate the mole fraction of urea, that is equal to small n by small n plus capital N, that is equal to 3 by 3 plus 55.5, and that is equal to 3 by 58.5, and hence it is equal to 0.05. Is it clear about the mole fraction? And we are going to discuss about one more important problem. So whenever you are supposed to find the concentration of 1.0 molar solution of phosphoric acid in water, we have to use the expression normality is equal to molarity into charge. So whenever you are supposed to calculate the concentration in terms of normality, we have to use normality is equal to molarity into charge expression. So in this present case, that is equal to 1 into 3. So finally the normality is equal to 3 normal. Is it clear, students? If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.